So coming to 2-bit comparator, so go to design sources and right click and then add sources, then select the middle one, that is add or create design sources, then go to next, create file, then we have to select vhdl, then file name our file name will be 2-bit comparator, then we will go okay, then we will finish. Okay, so here our model will be behavioral model itself and the port name will be a. There are two inputs, that is a and b, and both a and b will be of 2 bits. So here there is an option of we can see an option of this one is bus. Okay, select this. Wait a minute. See here bus will come, so select the bus option, and here msb and lsb will be there, so select put 1 in the msb and 0 in the lsb. So this will be a 2-bit number. A and b will be 2-bit number. Now output will be a. Our output will be a greater than a greater. Second output will be a equal, and the third output will be a less. Right, so these three will be output. We have to change the direction to out. Now click OK. Right here the files will be created. 2-bit comparator file is created, we can see. So we have to double click this file. We will get the code portion. Here we can see the code portion, right? So first of all, remove these comment lines to make our code look better. Okay, so remove these comment lines. Right, now coming to our program. Since our program is already written, right? So here let me explain the code. So here we have a and b as input. Here we can see that it has been created as a vector. Vector contains more than 1 bit of input. So here a is a 2-bit input. 1 down to 2 means a1 and a0. B is also 1 down to 2, 1 down to 0. 1 down to 0 means b1 and b0, right? Here we have three outputs: a greater than b, a equals b, and a lesser than b. So out these three will be as defined as out. Right, coming to the program, here the program is behavioral because we are defining the behavior, if, else, and so on. So here the program begin, and we will write process ab. So we have to do the process on AB. So we have to write process AB, then again we have to write begin, then we will check for if A is greater than B. If A is greater than B, then our A greater B variable will be 1, else the A equal B and A lesser B will be 0 0. Right, coming to A, if A is equal to B, then A equal B variable will be 1, else greater than and lesser than will be 0. Similarly, the third case will be a lesser than b, right? So we have to just write else. We don't need to write this a less than b. That's why here we can see that it is commented, right? So this is the case of a less than b, right? We have to write else. Automatically this is the case of a less than b. So here a lesser b will be 1, else other variable will be 0. Here we have to end the process. Now we have to save the file, right? We have to save the file, and then we have to go to RTL analysis, and then we have to click on schematic. So we will get so here a reload option is coming, so click the reload option. Right. After clicking the reload option, we can see the schematic, right? This is the schematic of 2-bit comparator. Here we can see that A and B are the inputs of 2-bit, that is A1, A0 and B1, B0, right? This is the internal circuit of the 2-bit comparator, and here we have three outputs, that is A equals B, A greater B, A lesser B, right? Now go to run simulation. Click on run simulation and run behavioral simulation. Right, we ran the behavioral solution. Here we have to now restart first. Restart, then we have to set the values. So here there will be A1 and A0. So we have to set it individually. So force clock, click on force clock, then go to binary, then set as 0, leading as a 0, trailing as 1, and this will be 200 nanosecond. Okay. Now A0 will be A0 will be again binary, and then leading as 0 and trailing as 1, and this will become 100 nanosecond because half of the previous input, right? Okay, now coming to B. So again this B will, again we have to do it force clock, and then we have to do binary, then we have to do leading edge as 0 and trailing edge as 1, and now this will be 50. This will be 50, that is half of the previous input, right? So this we have to do 50. Now b0, because b0 will also be binary, and again the leading edge 0, trailing edge 1, and now this will be 25, that is half of the previous input, right? Okay, now we have set all the inputs. Now we have to run this for 200 nanosecond, because the maximum period of first input was 200 nanoseconds. So we have to click on this. Here we can see that we got the graph. Now we will zoom fit it so we can see the graph, right? Now here we can see that we have to click anywhere. Suppose we clicked here, right? So this is A is our A is our 1, and we can see that B is also 1, right? Here and here B is also 1, right? So A equals B should be 1. So here we can see A equal B is 1, and A greater than B is 0, and A lesser than B is also 0. Here also we can check the values. So this is our final output.